Hello, welcome to 345 Tech Talks, and today we will be talking about how AI helps improve process optimization in manufacturing. I'm here with my colleague Danny, and we're just going to kind of shoot the breeze on this for a little while.
Yeah.
We're not going to go too deep on the tech. We're just going to just sort of give a bit of a flavour about the sort of things people are doing. So
Yeah.
so what we're talking about really, obviously in manufacturing, when when we're talking about process optimization, we're kind of talking about making, you know, making more stuff for less cost, and that cost can be, less material, it can be less energy, it can be less water, it can be less man hours,
Yeah.
it can be moving things over less distance. All those sort of things, but it's a pretty wide, it's a pretty wide range of things, and a lot of places, a lot of manufacturing in industries are, they're always focusing on cost and efficiency.
Yeah.
But they're kind of the traditional methods of doing cost and efficiency are kind of, uh, they're great, and because of a continuous improvement culture, making small changes, continue to tweak things. But with the advent of AI, we've actually almost got the possibility of making big leaps rather than making lots and lots and lots of small changes. We've actually got the ability to make some big leaps. So what are some of the areas, Danny, that you're seeing that people are using AI to optimize manufacturing?
Yeah. So this is a quite a fascinating subject actually, because I think what you tend to find when you come to manufacturing is how do we produce more product to obviously give us a bigger return, and that's always sometimes seems to be the first port of call, when actually
Yeah.
there could be an opportunity to actually save and cost save in the production line before you increase that product and the amount that you produce. So I think you mentioned energy right at the top.
Yeah.
I think energy is a really big player when it comes to cost saving now. Everybody is trying to find ways of not only producing, um, you know, more efficient ways to create energy, but also to save money on those costs as well. So I think
Yeah.
energy, heating and cooling is a really big player, I think, when it comes to AI and how that can really affect the bottom line of a major manufacturer.
Yeah, and a lot of that ultimately it comes down to data, doesn't it? That if it comes down to measuring practically everything. You're measuring your machines, you're measuring the temperature, you're measuring the temperature of goods going in, and so instead of necessarily, because again, you've some machines that do heating, for example, they've just got a heating element and they stick it on and things get heated.
Yeah,
Whereas actually, if you can like have something um, that can turn that heating up and down, if it doesn't need to be on full, you can just
mm,
like kind of really optimize that heat.
yeah,
In
yeah,
a lot of industries that are energy intensive, that can, energy is often the biggest single bill in a lot of factories, and obviously heavier industries even more so. So, even making 1%, 2% step changes in energy can lead to like huge sums of money.
massive. Yeah,
Yeah.
it does make a big difference.
Yeah, and that's, again, it's a bit like we were talking last week when you kind of one of the things that one of the things that machine learning models are really good at is when you've got a lot of inputs and it's difficult statistically to pick out the signal from those, um, because you've got all sorts of sensors giving you different information, and actually you're trying to find an optimum, or you're trying to find something, and
Yeah,
that's where machine learning is really good. And so you can put a control system in your plant that's got a machine learning model embedded in it that will be able to control things based on inputs from a wide range of sensors, and just find and be able to learn and predict just the optimum for that sort of thing.
yeah,
And this can go, and like I say, energy is a big one because it's quite easy to, in terms of control, it's quite easy to turn a heating element up and down.
mm,
It's you can maybe, if you're looking at cooling water, you can adjust the flow of cooling water. If you need slightly less cooling, you can turn it down. And energy and water, let's face it, they're the two big environmental impacts as well. So if we can do that, we're not only are we saving money, but we're kind of saving the environment as well.
Yeah,
So that's, it's like a double win, isn't it?
Yeah, absolutely. And everyone seems to be doing their part on that basis, which is what bigger corporations, I guess, and big businesses are looking to try and do is play their part. And AI can really help with that movement. Yeah, I'm interested in, obviously, like we spoke again, we spoke about our cans last week, and we spoke around the less raw materials. So I'm really interested in how, one thing is obviously the development and optimizing of our energy and our water, but also I'm quite interested in how we can use less material.
Yeah.
So I'm quite interested in what your thoughts are around that as well.
So again, there's I mean, this is a how long's a piece of string kind of question, because it depends on it really depends on what's being made.
I've put you under the cosh there. I'm sorry about
that. Yeah.
I've really thrown that one at you.
Yeah, you have, and because obviously in I mean, one of the things is that, for example, if you're I mean, let's say you've got you're cutting up pieces of metal.
Yeah.
There's always wastage when you're cutting up pieces of metal. So, but a lot of that is designed in at the start. But the interesting things is maybe where, because metal, you have it in fixed lengths, and if you cut it up and that sort of thing.
Yeah.
There's I think there's perhaps less in terms of process control. There's less going on there. I think the interesting thing is when you have irregular things. So again, a lot of natural products just aren't as regular. So for example, if you're a sawmill and you're sawing sawing up trees into planks of wood, or something like that, then each item is different, and so there's more capacity for kind of, in terms of applying machine learning and artificial intelligence in that sort of scenario, you've probably got more scope to optimization based on irregular natural raw materials. Like, one example is trees, and having to cut those up, and how you do that, and maybe in leather processing when you've got skins of leather.
Yeah.
Because how many shoes can you get out of a cow? It's not a fixed number, is it? And so there's each piece of leather, each hide, although they all follow the same kind of basic shape, because cows are cow shaped, that they're not the same size, and they're not exact. So that sort of thing is kind of where you can, I think you can be looking at those, measuring them, and then you've got to plot out the best way of using those materials. So in terms of yield, those are a couple of examples where you might be looking at doing that.
I think also that it also takes us back to what we were talking about last week, regarding finding the bad apple, if you like. So, like you said there, you said about the leather. If that leather comes through and it isn't quite, there may be some marking or something on it that's not quite right. This is where you can start to save on the raw product as well.
That's it, because if you've got because all these things are the natural products, but they can have imperfections on them. So if you've got, like, exactly like you say, that if you've got areas on something, on a piece of leather, or even on a piece of fabric where you've got imperfections, what you don't want to do is to let those imperfections get all the way through into finished clothing. So there's also, how do we make the most efficient use of raw materials, but there's also how do we make sure that when we're actually making something, that the finished item doesn't, the finished item isn't, doesn't have to be thrown out and discarded as second. So actually, that whole thing of quality control and raw material, and like you say, there might be one part of a piece of leather where you don't want to cut the shoes out from because it's blemished, and so there's there's the capability of doing that as well. That's a really good point.
Yeah.
One of the other areas where, one of the other things with manufacturing, particularly high volume manufacturing, is keeping the production line running. I mean, this is something that in automotive it's massive. It's like the cost of a oh, that's my dog going mad there. Don't worry about that.
It's usually one of our dogs in the podcast.
It's usually one of them. Yeah.
Roll. Yeah.
Yeah. Maybe we've got a delivery coming. But yeah, so one of the things we have is in manufacturing is keeping that production line running. What you don't want to do is to have when you've got hundreds of people on a production line, you don't want to have a line stop because it can cost tens of thousands of pounds per minute to have a line stop on a car plant. It's just cripplingly expensive, and so companies do preventative maintenance in that they know when they plan when the lines are going to go down so that they can service the machines, so that the machines are reliable the rest of the time. Now, what we used to do fixed service intervals, a bit like when you get your car serviced every year. That's a fixed service interval, but that's kind of a pretty broad brush. That's just kind of, you don't know whether it's that, but that's just kind of, we'll get it done anyway because just in case.
It's due. We think it might
because
be
it's due. And whereas what is much more efficient is to use predictive maintenance. So it's to be able to, so if you can have sensors in a piece of machinery that monitor how it's performing, and over time you can kind of detect that things are getting slightly worse, and then you predict when you need to have that machine serviced. What you can find then is that your service intervals are much more tailored to the machines, and there's always kind of a bit of a, well, you can't keep taking the plant down because each different machine is being predicted. You might, but you can maybe optimize those service windows so you're not just like, every Friday we're down for 2 hours to do machines, but it's like, but at least you might be able to say, well, maybe it's every other Friday or whatever. And again, that's something where we used to use statistical methods for that, but as machines get more complex and as we've got more sensors on them, we can track a richer amount, and that's why we start to use machine learning models for that, because they can be much more accurate in predicting when we need to do maintenance on a machine.
And would you look at that from a machine learning perspective? You would say, well, this machine has manufactured X amount of product, and that after that X amount of product, that's when we start to see this slight demise. So you start to put that data in and learn from that.
So, well, there's a couple of ways. I mean, it's always down to data, and it's always what's the best data and what things provide the best indicators. I mean, ultimately, there's kind of two areas on predictive maintenance that you're worried about. One of them is the machine will break down completely and stop working. And so you might be looking at things like, you might be monitoring noise levels, or you might be monitoring bearing temperatures, or you might be monitoring vibration and those sort of things. You might be monitoring temperatures and pressures. You might be monitoring those sort of things, because if any of those go out of kilter, you kind of think, well, this machine's starting to look like it's not happy. So in terms of is this machine going to break, it might be those things. And then the other thing is, this machine's going to keep running, but it's no longer making accurate parts.
So that goes back to the
quality
control type.
So then you're back to measuring the output of the machine. Is this what's the tolerance on this component? How far away from ideal is the machine on this component? And so measuring those things, and over time you can also kind of say, well, okay, we were making parts that are really perfect, and now they're getting a bit ropey, but they're still kind of okay. We're still okay, but by the time it gets to Thursday next week, this is this isn't going to be any good anymore, and so you kind of need to change the tooling or whatever, or refresh the tooling, or service it, or readjust the calibrations, or whatever it is. So there's that side of it as well. So it's kind of those aspects of predictive maintenance.
Yeah, that's fascinating.
So and the other thing, and I think probably we could talk about this all day, but probably for today we'll probably talk about environmental control as well, because this is very important in a lot of industries.
Yeah.
So, for example, pharmaceutical manufacturing, it's all got to be tightly controlled environment. You can't have contaminants. You can't have everything's got to be the right temperature, the right humidity, and then you've got also, but then you kind of also got to think, well, what are the other variables that affect that? And this kind of also feeds back into what we started with things like energy. But it's like if you can have a closed you can have a closed loop control system that monitors things like humidity, temperature, and just that's okay. But what happens with things like what happens with other data sets that you might pull in? So you might have data sets on your pollen, you have data sets on pollution, or weather, or things like that, and then you've also kind of think, well, maybe if you've got a really big building, it can take a long time to change the temperature in a big, if you've got a massive warehouse, or say if you've got a food processing plant that's like a huge warehouse that's refrigerated, it can take a lot of time to change the temperature on that. So maybe you need to combine that with weather, or predictions of the outside temperature, so just how much to. So you actually have to be predictive in what you do rather than reactive.
Yeah.
Because you need to get that. So those are some of the those are some of the areas there on environmental control. Again, it's in one sense it's sensors, but also you're kind of looking at other data sets and how you can combine data sets that maybe aren't within your control system, but they're other publicly available data sets that are going to affect you.
Yeah.
So those are kind of really those are some of the really kind of again, for really big volume manufacturing, that can make a huge difference.
You're talking a lot of from a cost savings perspective. You're looking at that and thinking, well, actually, there could be something in there, like you said, again, potentially millions of pounds worth of cost saving exercise that goes into these types of things.
But also it feeds into quality as well, because let's say if you've got you've got to make sure that for a lot of types of manufacturing, you've got to make sure that the environment is correct. Otherwise, it will affect the quality of the output.
Yeah.
And that's an important thing.
Absolutely.
Obviously.
Yeah.
So I think we can kind of wrap up there, because we could talk about this all day.
We start getting too deep, we'll end up at IoT devices when it comes to.
We will end up there, but I think one of the I think we're gonna carry on talking about manufacturing over the next couple of weeks. So next week we're going to talk about things like demand management and logistics, and some of the amazing things that are going on there. So thanks for listening, and we'll catch up with you next week. All right. Okay. Thanks a lot.
Take care,
Bye
guys.
now.
Thank you. Bye-bye.
Bye.